Neurotransmitters are chemicals that are naturally produced and released by neurons. 8 of them play the most major role in sleep and wake. Remember how REM looked more like wakefulness than non-REM sleep in that both involve low voltage, high frequency waves? Acetylcholine is the key neurotransmitter for producing REM and wake waves. Much is released during wakefulness and REM, but very little during non-REM sleep. Acetylcholine. Adenosine progressively builds up in the brain during wake time, like the sleep drive. Also, like the sleep drive, it progressively decreases during sleep. Caffeine can attenuate the effects of adenosine in intended ways. For example, when we take it to counteract sleepiness, and unintended ways. For instance, when we mistakenly drink a caffeinated beverage before bedtime and it takes longer to fall asleep. Gamma-aminobutyric acid, often called GABA, is widely used by the brain during non-REM sleep to dampen neural activity and reduce arousal. It plays a key role in producing the deep waves that we see in non-REM sleep and also the sleep spindles that we see in stage N2. It also works in concert with another neurotransmitter, glycine, to provide the muscle paralysis in REM sleep. Many prescription sleeping pills act by enhancing the action of GABA. Glutamate is an excitatory neurochemical. It is especially important for arousal, but it also plays a role in producing slow sleep and sleep spindles. How can one chemical be involved in opposites, arousal and deep sleep? By when and where it's released and how. Glycine, as we mentioned before, in concert with GABA, is responsible for the muscle paralysis experienced during REM sleep. Problems with levels of either of these can result in acting out your dreams. If you need to take an antihistamine, you should take it at nighttime, not morning, right? Because it will make you sleepy. It'll make you drowsy. So histamine is a neurotransmitter that produces wakefulness, which is demonstrated by the drowsiness produced when it is blocked by antihistamines. If you ever find your mind racing while trying to go to sleep, it is likely the result of high levels of histamine and glutamate. Orexin, also known as hypocretin, is also involved in the production of wakefulness and for preventing REM during wakefulness. Insufficient levels of orexin can result in narcolepsy, brief sudden sleep episodes during the daytime. This chemical has 2 names because it was discovered by 2 different labs at the same time, each which gave it a different name. Finally, number 8, serotonin regulates the sleep-wake cycle, regulates it. Your serotonin levels are highest when you are awake. They decrease significantly during non-REM sleep and are at their lowest during REM sleep. But note that some level of serotonin is always necessary. Serotonin deprivation messes up the sleep cycle in a way that produces restless sleep, waking often in the night. Serotonin is also important for sleep onset because it is needed for the pineal gland to make melatonin.